Hey everybody, John here. I'm going to talk about transformations of functions today, starting here on the computer so I can show you a little bit about the calculator. So first, let's talk about vertical shifts. So we have a function, the absolute value of x, and our goal here is first we should know, like I talked about in the last lecture, we should be familiar with the basic shapes of some of these functions that were listed in your book, one of them being the absolute value function. So we're going to graph the absolute value function. Then we're also going to graph the absolute value function plus 2 and the absolute value of x minus 3. We're going to graph them all on the same coordinate plane using our calculator, and then we're going to describe how g and h relate to the original graph of f. So f is what we would call the parent function for absolute value of x. It's the most simple absolute value function that you can have, and this is the one that we memorize the shape of, and then we can get any other absolute value graph from that. So that's our goal for today. So let's go ahead and put these in our calculator. So my calculator's here. So the first thing I'm going to do, if you have a TI-83 or a TI-84, this should be very similar to the setup that you're seeing on your own TI calculator, except your screen is actually above the keyboard here instead of next to it. So if we want to graph something, we're going to go to the y equals menu, which is right here. Before we do that, let me just give you sort of a rundown on the basics of a TI calculator. We have the buttons themselves that have something written on it, like this one says second. Then we have written in blue above the keys, we have certain things written down. This one says quit above mode. And then we have something for some of the keys written in green. Now, if you just press the button, what you're going to get is what's on the button. So if I press y equals, I will be put in the y equals menu. But if I hit second and then y equals, then I will be brought to the stat plot menu. And if I hit alpha and then y equals, I will be given F1, which is a key that we can use. So let's just go into the into the y equals menu. And if you do have, if any of these plots are highlighted up here, you can see mine are not highlighted. This is what it looks like when they're highlighted. If any of these are highlighted, just go up to them, hit enter so that they become not highlighted. And so I'm going to put in the absolute value of x. Now the absolute value can be found in the math menu on your keyboard. So I'm going to hit math, and then I'm going to go over to number, and the first choice is absolute value. So I'm going to hit enter. And if you have newer software, you're going to get this vertical bars that denote absolute value. If you have an older one, it's just going to say ABS, and then there's going to be a parenthesis. You're going to put the X, which is this button here. This is my variable button, in there. If you have an older one, you're going to close the parentheses so that you have the absolute value of X. Now I also want to graph the absolute value of X plus 2, and I want to graph the absolute value of X minus 3. Now I'm sure you can make a guess as what you think this is going to look like on your graph, and I suggest that you do that before you look at the graph. Make a guess about what you think this is going to look like. But I'm going to go ahead now and graph this. So I'm going to hit graph here. Now, if your graph isn't at the normal settings, it's a good idea here to go to zoom, and then we have our standard zoom standard, which is number 6. So we can just hit 6, and what it does is it sets the window from -10 to 10 in both the x direction and the y direction. That is our standard window is from -10 to 10. You can also look at the window settings in the window menu up here, and you can see I'm going from -10 to 10 in the x direction with a scale of 1. I'm going from -10 10 to 10 in the y direction with a scale of 1. And that's my standard graph. So here we are. You can see that the blue graph is my original absolute value of x. The red graph is the absolute value of x plus 2, and the black graph is the absolute value of x minus 3. So it looks like what's happening here, when we add something to a function outside of the function, and what I mean by outside of the function is here we have the function, and then outside of that we're adding c. If c is positive, then we're going to be shifted c units up. The original graph's just going to be moved up c units. So you can see that this blue graph has been shifted up 2 to get the red graph, but the shape of it is exactly the same. And that shape is up 1, out 1, up 1, out 1, up 1, out 1, up 1, out 1. The black graph here, since c is, well, we're saying here that c is still positive. If we subtract c, so if we subtract a positive number from my function on the outside of the function, the graph will be shifted c units down. And you can see that the absolute value of x minus 3 is shifted down 3 units, but the shape of the graph is exactly the same. It's still up 1, out 1, up 1, out 1, up 1, out 1. All right, so that is a vertical shift. That's how that works. Now let's look at horizontal shifts. Okay, so we want to graph f of x equals x squared, and then we're also going to graph g of x, which is x minus 2 quantity squared, and h of x, which is x plus 3 quantity squared. Now, this minus 2 and this plus 3 is definitely inside the function because the whole thing, the function itself is something squared. And because I'm subtracting 2 and then squaring it, this negative 2 is inside the function. It's being squared. So it's part of the something squared. So let's graph these on the same coordinate plane. We're going to use our calculator again. So I'm going to go back to my y equals menu, and I'm going to just clear this out. So I'm just going to hit clear on all 3 of these. And you can, if you're wondering what buttons I'm pressing, you can look down here at the history. Let me clear this out just to make it a little bit easier for you to see. So we want x squared as our main graph. So x squared is, I'm going to hit the variable button, and then I'm going to come here where it says x squared on the button, and I'm just going to do that. That'll give you your exponent. If you want a higher order exponent, you would use the caret, and that would give you that box there if you have a newer calculator. Otherwise, here we go we have our x squared. I can delete these parentheses if I don't want to see them anymore. So then in y2, I'm going to put I'm going to put parenthesis x minus 2, and that whole thing I want squared. And then in y3, I'm going to do x plus 3, and I'm going to square it. And so, again, just like we did on the last one, I challenge you to predict what's going to happen with these graphs. And before you actually go to the graph on your calculator, think about what you think is going to happen when we subtract 2 inside the function and when we add 3 inside the function. So remember, the blue is going to be my original parent function graph, which we should know the shape of. We talked about that before. That's my up 1, out 1, up 3, out 1, up 5, out 1, up 7, out 1, up 9, out 1. We're increasing by odd numbers, and we went over that in a previous video. So what do you think, how do you think the red graph and the black graph are going to compare to the original blue graph? So let's look. Here's my original, okay? My red graph, notice I subtracted 2 on the inside and that graph was shifted 2 to the right. So that might not be what you expected to happen. And my black graph, I added 3 inside, and that was shifted 3 to the left, which again might not be what you expected. And so the reason this happens is because when I plug 0 into x squared, I get 0. But I'd have to plug 2 into x minus 2 squared to get 0 because this is subtracting 2 first. So I'd have to put 2 in, which is 2 to the right. And I'd have to put in a negative 3, which is 3 to the left, to get my 0 back. And so even though this does apply for a quadratic, this works for any function. And so it turns out that any function, whether it's x squared or the absolute value of x or the square root of x or any function, if we are subtracting c inside, and again c is a positive number, we're going to shift c units to the right, which is the opposite of what you would think. When we subtracted outside, it moved down, and when we added outside, it moved up, which is what we would expect. But when we're subtracting inside, it's the opposite of what we would think, and it affects horizontal things. So outside the function is vertical shifts, inside the function is horizontal. Outside the function, it's what you see is what you get. Inside the function, it's the opposite of what you see is what you get. So when I subtract c units, I move to the right c units. And when I add c units inside the function, I moved c units to the left. Okay? So I will see you in the next video where we will talk about reflections in the x-axis. I'll see you there.